For the first time in over 400 years, we are faced with the possibility of witnessing one of the most fascinating celestial events in human history. A star explosion in the night skies, visible to the naked eye. Its name is Betelgeuse. Although the name may sound daunting, it might not bring disaster scenarios, but rather a tremendous explosion of light that will illuminate the sky, a spectacle unseen for centuries. Astronomers are watching this giant star with bated breath. So, what is Betelgeuse? It is a massive red supergiant that shines with a reddish-orange glow on the shoulder of the Orion constellation. Imagine it being about 800 times larger than our Sunday. If we were to place Betelgeuse in the position of our Sunday, its surface would extend to the asteroid belt between Mars and Jupiter. Recently, it has been behaving quite strangely. It suddenly brightens, then dims, almost like a pulse beating in the sky. Why is this giant so restless? Is it really about to explode? And if it does, what awaits us? Most importantly, is it a danger? Let's unravel this cosmic mystery together. Betelgeuse is about 600 light-years away from us. This means that the light we see now left the star 600 years ago. So, if it has exploded at any time within the last 6 centuries, that tremendous flood of light could be heading towards us right now. Perhaps it has already exploded, and we are just waiting for this cosmic firework to reach us. When Betelgeuse explodes as a supernova, it will be one of the brightest and most spectacular sights in the sky. It could be so bright that we will be able to see it even during the day, and this magnificent spectacle could last for weeks, or even months. Considering it will be so impactful even from such a distance, it is clear that the Betelgeuse supernova will be a massive release of energy. Depending on the nature of the explosion, it could even cause significant changes in the environment around the star. So, does this massive explosion pose a danger to Earth? Some scientists think that supernovae may have contributed to past mass extinction events. Traces of the iron-60 isotope have been found in ocean sediments and on the Moon. Iron-60 is produced in supernovae and has a half-life of about 2.6 million years. This indicates that relatively close supernovae have occurred in the vicinity of the solar system within the last few million years. It is known that gamma-ray bursts from nearby supernova explosions occur 2 or more times per billion years and have been proposed as the cause of one of the 5 largest mass extinction events in Earth's history, such as the Ordovician-Silurian extinction event that occurred about 450 million years ago. Fortunately, thanks to Betelgeuse's immense distance from Earth, we don't need to worry about this. However, for a moment, imagine if Betelgeuse were in the place of our nearest star, Proxima Centauri, 4.24 light-years away. In that case, the radiation released in an explosion would be so great that the possibility of Earth losing its ozone layer would reach enormous proportions. Gamma rays and other high-energy particles from the supernova would destroy part of the Earth's ozone layer, increasing the amount of ultraviolet radiation reaching the surface. Putting this dramatic scenario aside, let's focus on what separates Betelgeuse from other stars in the universe. For example, our own Sunday is about 4.6 billion years old and is expected to live for another 5 billion years. It consumes its fuel slowly and steadily, but Betelgeuse is nothing like the Sun. It has more than 15 times the mass of the Sun and is much younger, only 10 million years old, which is almost a baby in star years. However, due to its enormous size, Betelgeuse consumes its fuel at an incredible rate. And stars this massive don't live long, they live fast and die young. Right now, Betelgeuse is in the final stages of its life. As its hydrogen fuel has run out, it has begun to fuse progressively heavier elements in its core: carbon, oxygen, silicon, and finally, iron. Iron is the final stop. Fusing iron does not release energy. On the contrary, it consumes it. When iron accumulates in the core, there is nothing left to hold the star up against its own gravity. At that moment, everything happens very quickly. The core collapses in on itself, the outer layers of the star rush inward, bounce back, and are violently thrown outward in a tremendous explosion of light and energy. That is a supernova. What comes after depends on the mass of the core. If Betelgeuse is around 10 to 15 solar masses, it will likely become a neutron star, an incredibly dense, tiny object only a few kilometers wide but heavier than the Sun. If it's closer to 20 solar masses or more, it could collapse directly into a black hole. And the interesting part is, we still don't know the true mass of Betelgeuse. One of the main reasons for this is that we are not entirely sure how far away it is. Even a small change in its distance alters how we calculate its size and mass. This means we can't be sure what kind of death Betelgeuse will have. That's partly what makes it so exciting. Some scientists even think it could briefly become as bright as the full moon. But there's more to Betelgeuse than just its brightness. It's also behaving strangely. It's rotating very fast for its size. It completes a full rotation every 20 years, and its surface speeds reach about 18,000 kilometers per hour. This is a speed we wouldn't expect from a red supergiant. So why is it spinning so fast? One theory is that Betelgeuse swallowed a companion star in its past. Some astronomers have even given it a nickname like the Betelgeuse Companion. This would have given it extra angular momentum, causing it to spin faster. There is some evidence for this. For example, the outer layers of Betelgeuse contain more nitrogen than expected, suggesting that the star's interior has recently been mixed, something that could happen during a merger. Another possibility is that the observed rotation speed is an optical illusion caused by Betelgeuse's turbulent surface. Recent advanced telescope observations have revealed that Betelgeuse's surface is not smooth but is bubbling with intense activity. These massive convective cells can cause color changes on the star's surface, making it appear redder or bluer depending on whether it's moving toward or away from us. This color gradient may have led astronomers to believe the star is rotating faster than it actually is. To determine whether this bubbling or other factors are responsible for this color change, astronomers are focused on obtaining higher resolution images and more detailed data. So when will it explode? That is the big question, and the answer is, we don't know. Estimates suggest it could happen any time within the next 100,000 years. But again, due to its 600 light-year distance, it may have already exploded, and we are just waiting for the light to reach us here. This cosmic vigil reminds us once again how dynamic and surprising the universe is. Our eyes will be on the sky, waiting for Betelgeuse's next move.